Welcome back to section 2.6. We're going to be doing some more graphing. So once again, we're going to start. Now for this one, we'll start by factoring f of x. We'll factor the denominator. It's x over, and when you factor, you get x minus 2 times x plus 1. It's just going to make us finding those asymptotes a little bit easier. So the vertical asymptote, set x minus 2 equal to 0. You get x equals 2. And set x plus 1 equals 0, so you get x equals negative 1. So there's our vertical asymptotes. Our horizontal asymptote, so we have our degree of our numerator is 1, and the denominator has a degree of 2. So 1 is less than 2, n is less than m, so it's at y equals 0. Now we can find the x-intercept. It's the real 0 of the numerator, so x equals 0. And for the y-intercept, y equals 0 over 0 minus 2 times 0 plus 1. 0 divided by negative 2 times 1. 0 divided by any number is 0. So y equals 0. So our vertical asymptote first is that x equals 2 and x equals negative 1. Our horizontal asymptote is at y equals 0. Our x-intercept is at 0, 0. And our y-intercept is at 0, 0 as well. So we'll start by sketching out these asymptotes. X equals negative 1, x equals 2, y equals 0. Now let's make a table of values. Calculator's going to do all the hard work for us. Negative 3, negative 2, skip negative 1 because there's an asymptote, 0, 1, and then go to 3 and 4. So looking at the values, you get a negative 0.3, negative 0.5, 0, 0, 1, you get a negative 0.5, a 0.75, and a 0.4. So when you graph these, down here, you're just below. So on the left-hand side, it's going to look like this. And when you look at the middle of the graph looks like this. And you can see this is one of the cases where the graph does go through that horizontal asymptote. It's okay. It'll never go through that any other place except right there in between. And then on the right-hand side, it's going to look like this. So there's our graph. Our domain, we have 3 intervals from negative infinity to negative 1. The union of negative 1 to 2, and then the union of the interval of 2 to infinity. Our range, because we do go through that asymptote at one place, it's all real numbers, negative infinity to infinity. That's one of the cases where your graph does go through. So you have to look at it each time to see what your domain and range should be. Going to the next page, please. Number 11. So what we can do is we can factor this. F of x equals 2 times x plus 3, x minus 3, over x plus 2, x minus 2. It's going to make finding our asymptotes easier. The vertical asymptote, the zeros, so negative 2, and x equals positive 2. The horizontal asymptote, they both have the same degree, so y equals 2 over 1, so y equals 2. Our x-intercept, real zeros of the numerator. So 0 equals 2 times x plus 3, x minus 3. So x equals negative 3, and x equals positive 3. Our y-intercept, I'm going to use the original actually, just because it's a little bit easier. Y equals 2 times 0 squared minus 9 over 0 squared minus 4. So it's 2 times negative 9 over negative 4. So it's negative 18 over negative 4, which is a positive 9 halves. So our vertical asymptotes, x equals negative 2, x equals positive 2. Horizontal asymptote, y equals 2. X-intercept, there's actually 2 of them, at negative 3, 0, positive 3, 0. And our y-intercept is at 0 and 9 halves. I can actually label those right now. Now my asymptotes. And then we'll pick some values for our table, x and y. Negative 4, negative 3, then we'll go to negative 1, 0, 1, and then 3 and 4. So you got that 1.2, we got a 0, we got a 5.3, a 4.5, a 5.3, a 0, and a 1.2. So the left-hand side looks like this. On the inside, got a little parabola going on the inside there. And on the right-hand side, it looks like this. So there is our graph. Now our domain, we have 3 intervals once again. We're going from negative infinity to negative 2, and then we have the interval from negative 2 to positive 2, and the interval from 2 to infinity. Now our range is a little bit trickier. This is an OR inequality. It's starting here and going up, and then it's going below the asymptote. So we have a lot of different things to account for. So what we have here is for our range, we have 2 intervals. We're going for the lower interval, negative infinity up to 2 with a parentheses. And the union, now for the other one, it starts at 9 halves or 4.5, whatever you want to use. And it's going up to positive infinity. That's our range for this. A little bit trickier. And next, let's go to one more. X squared minus 9 over x squared minus 2x minus 3. So I'm going to factor x plus 3, x minus 3. In the denominator, we have x plus 1 times x minus 3. So you can see the x minus 3's cancel. So keep in mind, x cannot equal 3. X plus 3 over x plus 1, where x cannot equal 3. Keep that in mind. 3 is no good. That's where the hole in the graph is going to be. So for our vertical asymptote, x equals negative 1. It's the real 0, the denominator. Our horizontal asymptote, the degree are the same. So y equals 1 over 1, so y equals 1. So x equals negative 1, y equals 1. All right, so let's make a table. Oh, let's find our intercepts first. All right, so let's set the real 0, the numerator, x intercept, x plus 3 equals 0, x equals negative 3. And for the y-intercept, y equals 0 plus 3 over 0 plus 1, so y equals 3. So our vertical asymptote, x equals -1. Horizontal asymptote is at y equals 1. X-intercept is at 0, -1. Oh, I'm sorry, that's a -3. What was I doing? 0, -3. And our y-intercept is at 0, 3. So the graph, when we make a table, so when we're at -4, -3, -2, then we go to 0, 1, 2, 3, 4, and I'm actually going to go all the way to 5. Calculator's doing all the hard work for us. So we have 0.3, 0, -1, 3, 2. When x is 2, y is 1.7. 4, we're at, I'm sorry. Oh, we don't have something at 3. There's a hole at 3. Keep that in mind. There's a hole at 3. And then we're at 1.4 and 1.3. So when we graph this, like that, and over here, I'm going to draw through it. Try to. And then at +3, we have a hole in the graph. So keep in mind there's a hole there. So for our domain, we have 3 intervals because of that hole and the asymptote. -∞ to -1, the union of -1 to 3, and then union of 3 to infinity. Now the range is a little bit trickier because we have a hole there as well for our y's. So that range, that hole is probably about, y is about 1.5. So we'd go from -∞ to 1, the union of 1 to where the hole is at about y is 1.5 approximately, and then union of 1.5 to infinity. That range is a little bit trickier there because of the hole in the graph. Okay, I'll see you again in the next video to talk about another type of rational function. Thank you.